Hi, welcome back to our Algebra 1 playlist. On this video, we'll look at how to identify whether or not two functions are inverses. So inverse operations, if you remember, are like addition, subtraction. So if I had plus 6 and minus 6, those are inverse operations. They undo each other and you're left with nothing. Now if I were multiplying and dividing, if I had 5 times x and then I divided by 5, if I'm multiplying and dividing by the same number, those are inverse operations. Those would reduce as well, and you would end up with 1 times x, or just x. So whenever you want to find inverses, I want to know, do these functions simplify everything about each other? Do they undo the other's operations until you're left with just y equals x? So let's check this one. This first one, I want to know if negative 3x minus 9 is the inverse of negative 1/3 x minus 3. So to check if something is an inverse, we're going to do a composition of functions. I'm going to substitute one function in for the x value of another. So I'm going to take y equals negative 3x minus 9, but instead of x, I'm going to substitute in all of that stuff. So I'll do negative 1/3 x minus 3. That's step one. Can you substitute in the given values? So if I look at another example of 2x minus 7 and 2x plus 7, I'm going to substitute in that second expression where I see an x. So I would write y equals 2x minus 7, but instead of an x, I'm going to substitute in, let me do that in a different color. I'll substitute in the 2x minus 7 that is the other function. All right, let's try just writing down two more, right? Can you take a second here and pause this video and see if you can write this function where you would substitute in the second function for x? I would pause the video, try to write it out, and then unpause and check your work. And you should get y equals negative 4, but instead of x, I'm going to write negative 1/4 x plus 2, and then I'll remember to bring down that plus 8 at the very end. And maybe we can try that last one as well. I'd have y equals 1/2. And if you could pause the video again, try to write this one out. And then unpause to check your work. We've got 1/2. And I'm going to substitute in this value of 2x plus 7. All right, so that's the first step. The next thing you're going to do is you're going to try to simplify or combine like terms to get everything as simple as you possibly get it. And typically what that entails is you're going to distribute and then add or subtract. So I see a number outside of parentheses. I will distribute. Negative 3 times 1/3 is positive 1. Negative 3 times negative 3 is positive 9. And then I've got to bring down that negative 9 at the very end. And I'm going to simplify what I can here. So what here could I combine? I can combine my positive 9 and negative 9. And that's just 9 minus 9, which is 0. So you get y equals x plus 0, which is the same thing as just y equals x. And if you get that, you know that you have inverses. Inverses will always reduce to just y equals x. Let's try a second one here. Distribute first, and then add or subtract. So y equals 2 times 2 is 4. 2 times negative 7 is negative 14. And then remember to bring down that minus 7 at the end. And what can I simplify? I can simplify these like terms, 14 negatives and, sorry about that, 14 negatives and 14 negatives, 7 more negatives would get me 21 negatives. So I get 4x minus 21. All right, now if you have an inverse function, you get y equals x. So my final answer here is yes, these are inverses. If you don't have inverses, what you're going to end up with is some function, does not matter what it looks like, but it's not y equals x. So it could be anything in the world as long as it's not y equals x. Why don't you pause the video, try those next two, and then unpause to check your work. All right, so when you distribute, you should get y equals 1x minus 8 plus 8, and y equals 1x plus 3.5 minus 7. And when you simplify one more time, you'll get y equals x for this one, and you get y equals x minus 3.5. So on number 23, I got y equals x. Yes, those are inverses. And on 24, I did not get y equals x. I got y equals x minus 3.5. So those are not inverses. And that's how you would identify whether or not you have inverse functions